Okay, Lab 3 is about description of data and graph. Especially, you'll be able to graph three different experimental data. That's what you'll do. This will be a relatively short lab. Okay, first of all, data handling using statistics and graph. So those topics are covered in your chapters 15 and 16 in your textbook. So graphs are very helpful because they will visualize the relationship among your data sets. Okay, so whatever the graph pattern is that you're going to use, bar graph or pie chart or linear graph, it's much easier to see the relationship among your data if you can use the graph form. Okay, so you can construct a graph which will help interpretation of your data. So bar graph will probably be the simple form, and a lot of cases when you carry out an experiment you will use a linear line graph form. So you don't have to do that manually. Of course, there are softwares that are available, especially Excel will be a very helpful software that you can use to graph. Okay, so you will do a lab on Excel software today. And these are the necessary requirements for you to be able to plot an easy to read graph, because the main purpose of graph plotting is to visualize your data. So it should be very easy to understand what the graph shows, right? So first of all, each part of the graph should be easily identifiable. Okay, so maybe x-axis, y-axis, you should be able to understand what they mean, what values are shown up there, and then between x and y, what's plotted between them. Okay, and then evenly spaced marking on the axis should be good, so the data should be scattered all over the space, not cornered in one side. And no excessive color should be used. I know there are some people who love to use different colors, but doing too much would not be good. Okay, and no excessive graphics would not be good either. Not too many lines, bars, or segments. So make it simple and easy to understand. That's the key. If you're plotting a line graph, normally in your experimental design, there's an independent variable that should be entered as your x values, x-axis values. Okay, so remember the definition of independent variable versus dependent variable. So when you carry out an experiment, scientific experiment, normally the main treatment that's given to your experiment, okay, main value that's changed, that is considered as the independent variable. Okay, and then normally the main outcome that you are measuring out of your experiment, that will be considered as your dependent variable. Does it make sense? So let's say you are studying the effect of hormone treatment on plants and see how many fruits will be made from plants once you spray the hormones. Okay, in that experimental design, which one you will consider as the independent variable? Probably it's the amount of hormone that's sprayed on plants. That will be the independent variable, okay, because that's the main treatment that's given to your experiment, right? And in that case, then what will be considered as the dependent variable? Dependent variable will be the things that you will be measuring out from your experiment. In that case, how many fruits those hormone sprayed plants will bear. So the number of fruits from plants will be considered as the dependent variable. Does it make sense? So in that case, those fruit numbers should be entered on the y-axis, and the amount of hormone that's treated on the plants should be entered on the x-axis. So that's the basic rule in plotting a line graph. Okay, and then use easily identifiable symbols for data points. Of course, that's always helpful. And do not extrapolate beyond the measured data points. So that means do not estimate. Okay, so just enter whatever the values you measured, that's all. Okay, and you can also use statistics combining with your graphing, right? So good graphing tools will allow you to use standard deviation, coefficient variance calculation. Actually, you can have them show up on your graph, so that's easier to visualize. So those are the tendency of your data points, how close they are, how scattered they are. Central tendency of data points will be shown up by these values, right? You can add those values in your graph as well. Okay, so advanced analysis like curve fitting equation, R-scale value, linear fast fit line, those can be also plotted. Those are really important because when you use something called standard curve in your assay to estimate the unknown amount of your proteins or whatever that you're trying to measure, you have to have that equation from your best fit line or curve fitting line to be able to do the mathematical calculation. So we'll understand what that means by plotting some graphs today. So customized calculation, data analysis packages done through statistical analysis, and there are softwares like SAS, SPSS, those are available. But for this class, you will be mainly using Excel software. Okay, so let's practice data handling using Excel. Now you'll be able to plot a graph, and that graph can be copied and pasted on your lab report. So that'll be a very handy tool for you. So what to understand? So how to plot a linear graph? So you'll be able to do that by doing this lab using Excel, and with its fast fit line. So if fast fit line calculation is needed to estimate the unknown values, you definitely need that along with the exponential, or along with the equation for the line. Okay, and how to plot an exponential graph if your data has unusual values, exponential value, then how you plot that, and how you plot also the linear, change that to the linear form to get the best fit line. You're going to practice that, and how to use basic statistical tool in your data analysis, in your graphing. How do you do that, like average or standard deviation? Okay, you're going to practice that today. So exercise number 1, you will be asked to plot a graph based on this table that shows your data. Okay, so in this table, what's shown up, like I said, is some plants were treated with the hormone, a different hormone level, like no hormone was treated, so that's probably the negative control. And then 3 milligram per liter, 5, 10, it goes beyond, okay, up to like 60 milligram per liter amount of hormone is treated on maybe plants. I don't know what that hormone is, it's not showing up there. Maybe it's a ethylene hormone, whatever. Okay, and then you measured the amount of fruits that are being bared from those hormone treated plants. Okay, it's 3.2, 3.7, seems like it's an average value from number of plants. Okay, so you have this data set. Okay, and the question is, can you plot this on a graph so you can see their relationship more easily? By looking at these numbers, it's hard to see, when you increase the hormone level, what happens to plant and their production. If you look at it carefully, looks like, yeah, the more hormone is treated, there will be more fruit that's being produced, right? So that may be it, but if you plot it on the graph, it's much easier to visualize that relationship. So let's practice that. I pre-plotted that on an Excel form. So here, so the same data set, so you can open your Excel, okay, on your computer and enter those values on the first 2 columns. The first column, maybe you can label as hormone level, milligram per mil, and then enter those values from 0 to 60, so from the table. And the next column, B column, you enter the fruit production level, okay, from 3.2 all the way up to 36.5. Those are the values that are given in your PowerPoint slide. Okay, once that's done, you can highlight those 2 columns, okay, and then go to the insert option in your Excel, and then click on that little arrow there. So that's a chart option arrow. If you click on it, it's going to recommend you what chart is the best chart to illustrate what you just highlighted, right? This is giving you, that linear graph function. So if you say, oh, that looks good, say okay, and there you go. That's the graph that's showing you the relationship between these 2 columns, right? So of course the graph doesn't have the axis labeled, so you can enter those axis label and all those things. So for example, here this is a plus symbol. If you click on it, you can add some options on your graph. For example, axis, so the axis title, like I said, you can add axis titles there. Okay, and then maybe y-axis in this case is showing you what it's probably it's the hormone level. Okay, automatically it entered the B column onto the y-axis values. So you can type up there as what hormone level in milligram per liter. Type that, see, it shows up on the y-axis as an axis title, and the x-axis was what? Was average fruit production per plant. So we enter that there as well. Okay, so there you go. Okay, so that's the trend you can see. So there's kind of linear relationship. So the more hormone is added to the plant, you see what? The more fruit production. So that's showing up there. Okay, so you want to add more things like, so like the title of the graph, yeah, average fruit production per plant. Actually, that's not the title, right? That's not the correct title. So you can click on that and then add more appropriate title. The more appropriate title will be what? The effect of hormone on plant fruit production or something like that, right? Okay, so that'll be the title for the graph. And then if you wanna present the best fit line, because this line here is not very linear, right? Because there are some statistical experimental error. Okay, so to minimize that, you can you can visualize something called the trend line. Okay, so there is, if you click on that plus symbol again, there are these options. So click on maybe the trend line option. Okay, if you do that, you see those dotted line. That's the trend line that's calculated based on your data values. Okay, so the best fit line is the linear line that will go through most of your data points very closely. Okay, that's the best fit line. Okay, so that trend line can show up there. Okay, and then not only that, you can also, by click on here and go to more option, you can also have something like equation on the chart. Okay, the equation of this trend line, what that is. So equation is what? The mathematical relationship between x and y values. That's what this equation is. Y value equals 0.6372 times x plus the y-intercept, which is 2.3712. So that's the mathematical relationship between x and y values. That's displayed by this trend line, right? And then also you can have the R scale value show up there. R scale value is what? That's a value that shows up how this trend line is close to your actual data points. That's what R scale value is. If your trend line is good, the R scale value should be above 90%. Okay, so the higher the R scale value is, you know, your trend line is true for your all data points that are represented. So normally R scale value that's above 90%, like 0.9, is acceptable. But if it's lower than 0.9, there's something wrong with your trend line. Okay, so R scale value is really handy for that. Okay, so you can have those show up there. Okay, so I think that's the basic things about graphing you need to know. Yes, how to plot a simple linear graph and how you label your axis, y and x-axis. Normally y-axis is what? Your dependent variable, and x-axis your independent variable. And the title of the graph, of course, you need to enter. And then if you want, have the trend line show up. Okay, click that plus symbol, choose that trend line. And then if you want the mathematical equation, go to that little triangle. Okay, and then more options. Okay, and choose display equation and the R scale value, and then that will show up there. Okay, so that's pretty much simple graphing I guess tips for you guys. Okay.